Part 1. For quality control purposes, in part 2, we are going to be working with 10 pens taken from a box. So if I were to let X be the number of 40 pens chosen from this random sample of 10 pens, then X here will be following a binomial distribution out of 10 pens. The probability of a pen being faulty is 6%, so 0.06. And for a box to be accepted, out of these 10 pens, there must be less than or 2 number of faulty pens. So we are going to be working with the probability that X is less than or equal to 2. And pressing this into the calculator will get us the answer that we want, and that is equal to 0.981. The first thing that we should try to do in part 3 is to calculate for the probability that one box is going to be rejected. In part 2, we have already calculated for the probability that the box is going to be accepted. So for it to be rejected, it's going to be the complement of this, so 1 minus this, which is going to get me a 0.018838. And if we were to let Y be the number of boxes that are rejected out of the 75 boxes, Y over here will also follow a binomial distribution. Out of 75 boxes, the probability for one of the boxes to be rejected, that is 0.018838. And what we want to do now is to find the probability that more than 5% of the boxes are going to be rejected. So it is the probability that Y is more than 5% of this. So it is going to be more than 5 over 100 of 75. So we are calculating for the probability that Y is bigger than 3.75. And since Y is a discrete random variable, since it's the number of boxes, so Y is going to be bigger or equal to 4. And to calculate this, because of the restriction of my calculator, I'm going to try to re-express this as 1 minus the probability that Y is less than or equal to 3, so that I can work on probability that Y is equal to 4, Y is equal to 5, and so on. And pressing this into the calculator get me my answer, and that is 0.0535. In part 4, we are going to be letting W be the number of 40 pens chosen from the 5 pens that are taken from the box. And we need to be able to identify that W here will follow a binomial distribution. Out of 5 pen, the probability of success, the probability of a pen being faulty is 6% still, so that is 0.06. And the probability that we are supposed to find is for a box to be accepted. And according to the description that is given to us by the question, there are going to be 3 cases. The first case is obvious. It is when there are no pens that are faulty, and that will be when probability of W is equal to 0. The second case will be when W is equal to 1. We found 140 pen out of these 5 pens. And when this happens, a second trial is going to be conducted. And because the question says that in order for the box to be accepted for this second trial, the total number of 40 pens must be a maximum of 2. So we already found 140 pen, which means that for the second trial, W must be less than or equal to 1, so that I can have a maximum of 2, or maximum total of 240 pens. And the last case is when we found 240 pens. And for the second trial, because in total there must be maximum of 240 pens, so for the second trial there must be 040 pens. We will not go for W is equal to 3 because that will mean that the box is going to be rejected. And we are talking about acceptance here. So we're going to calculate the probability for all these 3 cases. This, if I were to press into the calculator, this is 0.73390. Probability that W is equal to 1, pressing into the calculator, this is 0.23422, and this is equal to 0.96813. This, from the calculator, is 0.029901. As for this, in the calculator, it is 0.73390, which is the same as this. So my final answer is 0.983. In part 2, we have calculated the probability of a box being accepted using the original testing procedure, and we found that it was 0.981. And now, in part 4, we made use of the alternative testing procedure, and we found that the probability of accepting a box has increased to 0.983. And as a factory, I guess there is this motivation to have more boxes being accepted. That is why in part 5, when the question asks us why is it that the factory manager may be preferring this alternative testing procedure, that is because the probability of getting a box accepted is higher when we are using the alternative testing procedure.